So welcome everyone to my talk on the reducing entry barriers for online programming exercises, Theia in an education environment. So as most of you probably know, it is incredibly hard to onboard developers to a new project. And there are plenty of reasons why that is. So you could have problems with the tech stack or with the installed software on your Mac or PC. There are plenty of nitty-gritty details that you need to figure out to get a new developer on the team. And these are experienced people. So you could imagine onboarding students into a new project, into a new course is incredibly hard as well. And it is also very important that these people who are just getting to learn the programming in general, or also interacting with these tools, get on board quickly so they can actually start learning. So wouldn't it be great if you could just open a website, type in the URL of maybe your company or your university, select what you actually need, in this case, maybe Java, and then just wait a couple of seconds. And before you know, you are in your IDE that is pre-configured for you exactly the way you actually needed it to be. So this is what we were talking about today. And let's see how this actually works. But before we dive into that, I would like to quickly introduce myself. I'm Matthias Linhuber. I'm a doctoral student at the Technical University of Munich. I'm an educator at heart, and I would describe myself as a software and infrastructure architect with the main research areas: container-based software engineering, infrastructure orchestration, and also scaling education technology to a real high number of students. But I'm not alone, so I have a couple of very nice human beings in my team, especially Dennis Jando, Yannick Schmidt, Robert Jando, and our professor Stefan Krusche, who are working hard to make everything happen that you will see today. We also have a few industry contacts, especially Jonas Helming is here to mention. Without all these help from the Eclipse side of things, nothing of this would be possible as well. So to give you some context, what will we talk about today? We are the Technical University of Munich in the School of Computation, Information and Technology. So we are a big university based in Munich, Germany. And today we will only look at the computer science department and the school that it is located in. In this school, we have 130 plus professors. We have plenty of doctoral candidates, so over 1,600 doctoral candidates, and equally as many staff members, so non-academic people who are making everything possible for the students. Speaking of students, we have over 50,000 students, which is quite a lot already. Roughly 50% of them are international students and 22% are actually female students, and we are really proud of that. But of course, we can always improve to get more people here, or more, especially more females, into computer science. So if you hear 15,000 students, this is quite a lot. So our courses are actually also quite big. So we have huge lecture halls like this one. And most of the time, especially in the foundational courses, we even stream the same lecture into multiple huge lecture halls to get a seat for everyone that needs to participate in the course. So as you might imagine, it is really hard to get everybody on the same page, especially with such a diverse set of students. So we at our chair employ a technique called interactive learning. And I would like to give you a quick introduction into that, because it's really difficult to understand everything else if you don't understand how we actually teach programming. So we start off with a course syllabus. And as you might imagine, we have plenty of topics in this course syllabus. For every lecture, we select a topic or multiple topics and break it down into one or more learning goals that we would like to convey in this lecture. And starting from that, we then dive into the learning part. So we give the students some theoretical background on the topic, on what we will talk about in this lecture. And then we might give a small example where the students can actually see what we were talking about and maybe have the first glimpse into some real world application here. And then we want the student to actually participate. So they have to practice and they need to get feedback. But if we are in a course setting with 2,000 or 3,000 students in the same course, this becomes incredibly hard to do. And what we actually want to do to make it interactive, we want to have multiple cycles of practice, getting feedback on what you did, and then practice again until you really understood the concept that we were talking about. The ideal outcome is then some kind of reflection, so the students actually gain something from that. And this process will be repeated multiple times over the course of the semester, and so in some cases, even multiple times per lecture. This is what we call a learning sprint. So the students get a good view into some very detailed parts. They have an example, practice, feedback multiple times, they get a reflection, and in the end, we hopefully have a knowledge increment for the student. So this is closely like lean towards the Scrum Agile method. So you will see lots of parallelisms here. So this is working really, really well for us. And if you're interested in that, we can have a chat on that in the chat later on. To support this interactive learning approach, we built a tool. It's called Artemis. It is an online learning platform, which is currently used in over 13 universities in the German-speaking part of Europe. We also have a few external ones in Georgia, for example. It's a heavily developed tool, so we have at least one release per week with 20+ developers, and it's also LTI compatible. So for those of you who are in the education game, you might know LTI. So this is a tool that can be actually integrated into other learning platforms as well, if you prefer to have a second tool for the main like parts of your lecture and just use Artemis for the interactive learning part. We used Artemis for 80,000 students at this point, so plenty of people have experienced Artemis as a tool in 200+ courses, and even 15,000 students wrote an exam in this tool. So this is pretty well known at our university, and the users actually really like the concept that is behind Artemis. So Artemis as a tool supports a few different exercises, so programming exercises, some quizzes, text, and also UML modeling. It is built for scalability with usability in mind, and the most important thing for us is the instant feedback. So for today, we only look at the programming part. And here is an example for a programming exercise in Artemis. So as you can see, we have an observer pattern, example exercise here, and you have some kind of problem description, and then you have a clear list of things that you are expected to work on. And as soon as you're done, you hopefully got a good score, and Artemis will tell you that you completed all the sub-exercises in a good way. And in case you didn't, it also provides you with some feedback. So what is the problem with this approach? There are so many things that we simply assume that is quite a challenge for the students to get right. So we start off with a simple starting the exercise, and then the student might need to clone the repository, open an IDE, implement some kind of solution, maybe test the code, run the code locally, push the code to Artemis so it can actually be assessed, get some feedback, and then student needs to assess, am I done with the exercise? Is everything the way I want it to be? Is Artemis happy with me? In case it's not, we need to re-implement as a solution, maybe test again, push the code, get the feedback, and at some point we are hopefully done and we can complete the process. But there are things that we simply assumed that they are easy for the students and will work out fine. So we, for example, assume that everybody can clone the repository. Everybody has Git installed and knows how to use Git in a way that this is useful to solve the exercise. We also assume that everybody has an IDE that is working and is configured correctly. And we also assume that students are able to run code, whatever that means. Maybe they don't have Java installed for a Java exercise. Maybe they need a different kind of programming environment for a different lecture. So lots of assumptions. And if you think about it, the main goal that we would like to achieve is actually to teach them how to program. So if we reassess these activities, actually only starting the exercise, implementing a solution, and getting the feedback is really important for the student. Everything else, it's just stuff that needs to happen in order for the students to actually implement a solution. So how do we get rid of all these problems? One solution is to look at pre-configured online IDEs that actually have everything installed, and you can be sure about that this is working for the respective exercise. So let me motivate this in a more structured way. So we have three main motivations that we'd like to point out today. The first one is social. So we have very interdisciplinary students. We have, of course, the CS majors, so everybody who is studying computer science in one way or the other. But we also have plenty of other disciplines that would like the students to learn some kind of programming. So economics students or even just the students would like to have at least a basic understanding of programming. We can, of course, assume that everybody has some basic knowledge in how to turn on a computer, but we can never expect everybody to understand how an IDE is installed on your machine. There's also this argument of inclusion and accessibility. So not everybody has a really great PC or a really great Mac to work on. And maybe especially for the people that don't are CS majors, they might just have a simple iPad to work on because it's plenty for their studies. But for programming, maybe not so much. So we want to actually have a good foundation for everyone to work equally. We also have the technology side of things. So as I said, IDE setup is very complex, and maybe you need multiple different IDE setups for different lectures. So you have Java, maybe you have some kind of functional part with Haskell or Camel, or maybe you have lower level stuff like C or assembly. So you need to have your stack right for all these things. And this is especially for newcomers, very, very difficult to get right. And I think this is also something that we pointed out already. The focus is actually on programming and not on setting up your IDE to work in every circumstance. And one argument that is maybe not so clear is also constructive alignment. So it is a concept that is something that is really important to us at our chair, that we actually train the people the way they will actually use the technology later on. So we want to actually teach programming in an IDE. And we want to actually also assess people in the same environment. It doesn't make sense to learn programming in an IDE and then have the exam on paper where you just write code with your pen. So this is definitely also something really important for these online IDEs motivation. As a solution, we opted for Theia Cloud. I think you already heard a lot about Theia Cloud yesterday. I believe there was a talk about it. So just to get everybody on the same page, it's basically Theia in a browser, and we have some nice infrastructure in the backend where we can simply assume it works as a user, and you can use the IDE the same way as you're used to on your local machine. In addition to Theia Cloud, we also developed a little tool called Scorpio, which is an integration of the Artemis learning platform right into the IDE. So we have this little sidebar where you can actually see all the tasks that you have to complete and also the problem statement, of course. Good. So now let's dive a little bit deeper into the technology. So I brought you this diagram and I will guide you through, so no need to be scared of all the lines. I will just try to explain that real quick here. So on the left-hand side, we have the Artemis cluster. So this is, again, our learning platform. And this is a very simplified diagram here. So you can just assume we have some kind of user management, and we have a component that provides programming exercise functionality. So the programming exercise component will expose two services for feedback and for obtaining the exercise. And this is actually where Scorpio is talking to. So Scorpio assumes these services to be present, to get the problem statement, and to also receive feedback after the student submitted something. It also uses the online IDE Theia landing page, which is running on a Kubernetes cluster, to start a new session for the student. And the session then homes the Scorpio plugin and, of course, the IDE itself, so it can actually be used by the student. This is achieved by talking to the Theia Cloud orchestration service. which is basically there to schedule all these sessions on a Kubernetes cluster in a usable way. And we have some key cloak authentication also running side by side here, just to make sure that every student is actually authenticated, and we can actually make sure that every student only has access to their respective session. Good. So this is the basic architecture. I think on this level, it's easy to understand, at least to a certain extent. And I would now like to dive into a little demo. So we now have a look at the flow that the student actually would have when they want to use the online IDE. So first off, student selects the course he or she actually want to participate in at the moment and find the respective exercise. In this case, we have the exercise merge algorithm in Java. So we want to have some kind of sorting algorithms, and we also have an interest in the strategy pattern. So plenty of tasks to do, and the students will just click, look through the problem statement, and then just click the code button and select which type of IDE they want to use. In this case, the student opted for the online IDE, and the online IDE starts up. And as you can see on the left-hand side, we already have the respective folder cloned. So all the scaffolding for the student is already there. So we can take a few more minutes, get familiar with the code, have a look at all the to-dos, and then start coding. And in this case, our student actually opted for checking out the TheiaCon. So we have a little greeting here. And this was maybe a bit quick, but what you saw there is that actually Theia uses also a language server. So the student, maybe we show that one more time, just typed in st_out, and the language server completed that to system out print line. So you can actually see we have some background functionality in there that supports the user in writing their code. And this is also something that you would have on the local IDE as well. So this is really, really nice that we can just have that in the browser now. Good. So we have written some code, and now we want to actually run it. And this is also something that we can do just in the browser. So you can just click the play button, and you can actually see the greeting sentence is actually printed to our debug console. Nice. Okay, now let's really dive into the code and implement some stuff. So for now, we opted to just implement the bubble sort algorithm, and then we can submit the exercise. So we stage everything here in Git that we want to submit, type in a nice message, and push it to Artemis. And if you look back into Artemis, then we can actually see we have our first exercise completed, and 1 of 1 test is passing. Great. So this is how our user flow looks like. And this also concludes the demo. So what we contributed up until now, we have prepared Theia blueprints and app definitions for plenty of languages. So we currently support Java, C, JavaScript, Swift, Rust, Python, OCaml, and TypeScript, and many more to come. We implemented a custom Theia landing page that actually supports 2 things. The exercise auto start. So this is what you saw in the demo, where you just click on start exercise and you are guided into the respective app definition that you want to work on. Or we also have the playground mode. And this is what you saw at the very beginning of this presentation, where you could select an empty pre-configured IDE for Java, for you name it. And we also implemented an integration between Theia Cloud and Artemis, which is called Scorpio, the plugin for Theia, or also for VS Code. So some future work. So we are definitely interested in testing this in a real-world scenario. So we will give out this solution to plenty of students, and we will conduct a little bit of user satisfaction surveys and hope to get also scientific background and also prove that this is a good solution. On the technical side, we are interested in pre-warming and predictive scaling. So as you can imagine, this is a quite elastic scenario that we are working in here. So if you imagine 2,000 students in a lecture hall, and everybody would like to just start up an online IDE to work on some exercise, this is quite a heavy load, and we need to be prepared for that. And this is something that we will work on in the future. So this concludes my talk. Thank you for listening. Thank you so much for the interest, and I'm open to questions.